Hi guys, so for today's lesson we're going to be dealing with scale drawings. What do I mean by a scale drawing? So it's a picture of an object or place which has been enlarged or shrunk in the correct proportions. What do I mean by correct proportions? Well, when you enlarge or shrink something, you need it to still look right. You need everything to be sort of the right size in relation to each other. So I've got an example of a scale drawing right here in the form of a map. So this map has shrunk the town of Orange into this small area where we can see the whole thing. And you'll notice that things like the roads and the distances from Orange to other places, they're all in the sort of, it looks right. They're all in the same sort of proportions with each other, if that makes sense. So that's what a scale drawing does. If something's to scale, it's drawn properly, but it's just going to be either enlarged or shrunk down. So we know exactly how much it's been enlarged or shrunk by because we will be given a scale ratio. So what do I mean by a scale ratio? It's a ratio that compares the length on the drawing first to the length in real life second. So, and notice that the same units are needed. So this ratio, we've got the first number as 2. That represents a length on the map. And this 500,000 represents a length in real life. So the map section always comes first, and then the real life section comes second. So e.g., this ratio here, this scale of 2 to 500,000, as you see here, suggests that 2 centimeters on the map. So the map part comes first. You've got to remember that. That 2 centimeters represents 500,000 centimeters in real life. So another way to say that is that 2 centimeters on the map is equal to 500,000 centimeters in real life. We can convert this to nicer units. We can convert 500,000 centimeters into 5 kilometers. So 2 centimeters on the map roughly represents 5 kilometers in real life. And that kind of does make sense. Like maybe that length there, that kind of looks about 2 centimeters to me on this map. And from this spot here in real life to this spot here in real life, that would roughly be about 5 kilometers. And that makes sense. That's what our scale is telling us. So we need to be able to do these sorts of calculations ourselves. The next term that I need you guys to be aware of is the term a scale factor. So when we create an equivalent ratio to the scale ratio with 1 as the first number, it's all about making a ratio, a new ratio that's equivalent, with 1 as the first number. The second number in this ratio is the scale factor. So the scale factor is some sort of number, and we can figure it out by looking at the second number in the ratio when the first number is 1. So that's probably a little bit confusing, but let's do an example. So the above scale ratio was 2 to 500,000. That's what we gave you. Now we want to figure out the scale factor. The way to do that is to make the first number become 1. So how do we do that? Well, what you do to one side, you want to do to the other side. So if I want this to turn to 1, I'm going to divide it by 2. Because 2 divided by 2 is 1, so I'm literally going to look at this number and divide by that same number. And 500,000 divided by 2 gives you 250,000. So we get this equivalent ratio. 1 is the first number, which is desired. The second number is what we call the scale factor. So 250,000 is our scale factor for this map right here. Okay, so let's go through a few rules to remember. So the scale factor, so this number here that we found, is the key value for converting between real life and scale drawing distances. So really important to remember this concept. So the scale factor is a really important number to be able to find. So if you want to go from the scale drawing to a real life distance, so scale drawing to real life, you want to multiply by the scale factor, whatever number it is. And if you want to go from a real life length to a scale drawing length, you want to be dividing by whatever the scale factor is. So a really important concept. When do you multiply? When do you divide? Really important to remember. Okay. Note, use appropriate units whenever you can. Don't forget your length conversions. So you need to remember how to go from kilometres to metres to centimetres to millimetres by using these multiplications and divisions wherever you need them. Because we don't want to be dealing with like a very small amount of kilometres or heaps of millimetres. We want to be able to convert them to units which make a bit more sense in the correct context. Let's do some example questions. So a map has a scale of 6 to 20,000. So remember that 6 is the map lengths, and 20,000 is the real life lengths for this ratio. So what is the scale factor? So first thing we need to think of is to make 1 the first number. And the way to make this 6 become a 1, we got to divide it by the same number, 6. So 6 divided by 6 turns the first number into a 1, which is what we were planning to do. And then 20,000 divided by 6, that becomes 3333.3 repeater. Now, this second number here, that is going to be your scale factor. And I've converted that into a mixed numeral. It looks a little bit nicer than recurring decimals. So that is your final answer. Okay, question B. A bridge on the map is 4 centimetres long. How long is the bridge in real life? So this is converting from the map to real life. How do we do that? Well, this is where we need to use this strategy here. We're going from the scale drawing to real life. We need to multiply by the scale factor. Make sure you're multiplying, not dividing, because we want to go to real life. So we've got to use multiplication. So we take our 4 centimetres on our map and we're going to multiply by the scale factor of 3333 and a third. We do that in our calculator, we get this. And again, and that's in centimetres. The reason it's in centimetres was because our length here is in centimetres. So the units will not change when you do your scale factor conversion. We don't want to deal with this many centimetres, so we're going to divide by 100 to convert to metres. We're left with 133.3 repeater metres, and that as a mixed numeral is 133 and a third metres. Again, the mixed fraction is just a little bit nicer in this context. Question C. The main road has a length of 13 kilometres in real life. How long is the road on the map? So now we know the real life distance. We want to go to the map distance. So this is where we're going from real life back to the map. So this is where we need to divide by the scale factor. So we take our 13 kilometres and we're going to divide by our scale factor. That gets you 0.0093 kilometres. Notice kilometres stays kilometres. The units will not change. But we don't want to deal with such a small amount of kilometres, so let's convert it to metres. So therefore, our 13 kilometre road is going to be equivalent to 3.9 metres on our map. So it's quite a big map. It's like going to be almost 4 metres long. So you need a very big map to pretty much fit this whole road onto the map with the scale that they've given us, this scale of 6 to 20,000. Okay, so question 2. Determine the scale factor for the following situations. So, part 1, 4 millimetres on a map represents an actual distance of 50 centimetres. So, 4 millimetres on the map, 50 centimetres in real life. That's the way you need to think. So the map part comes first, our 4 millimetres comes first, and our real life distance comes second. Now, notice that we've got different units, millimetres and centimetres. We need the units to be the same, so we're going to convert our 50 centimetres into millimetres so that they match. So it becomes 4 millimetres to 500 millimetres. And that, we can just get rid of the units now because they're the same. So that's 4 to 500. And we want to figure out the scale factor. So we need our first number to become a 1. So we're going to divide both of these things by 4. 4 divided by 4 gives us 1. And 500 divided by 4 gives us 125. Remember, the second number is what your scale factor is. Okay, next up. An actual length of 0.1 millimeters, so a very small length, a tenth of a millimeter, is represented by 3 meters on a scale drawing. So remember, first part of your ratio is your scale drawing. That's 3 meters. Your scale drawing is 3 meters, a really big drawing. So that comes first, 3 meters. The 0.1 millimeters comes second, because always your real life measurement, the actual length, comes second. And now we got to make these units the same. So change your 3 meters so it becomes millimeters as well. That becomes 3,000 millimeters and 0.1 meters over here. We need this first number of 3,000 to become a 1. So we're going to divide both of these numbers by 3,000. 0.1 divided by 3,000 becomes extremely small, 0.00003 repeater. And I can convert that to a fraction form, which is a little bit nicer, because this is our second number. We want it to be as in nicer form as possible, and that's 1 over 30,000. That is your scale factor. Okay, hope this helps you with the questions. Good luck.